Actually, let me make sure if my audio set up right. Yes. Okay. All right. So we're going to talk about functions just in general first. Functions are not a P5 thing specifically. They're just a general programming concept. And they're not even specific to JavaScript. They're used in every single programming language, basically. So they're really a pretty fundamental part of programming. We'll go over the basic idea of a function, and then we'll add it into a P5 sketch. So um, we have been using functions all semester, so that's a good thing to point out is that, of course, we've seen the word function in a lot of our sketches. When we create a sketch to start with, there's the default blank sketch that when we start a new P5 project has two functions in it. It has the setup function and the draw function. And then there's the create canvas, which is a function, background, which is a function. So we've actually been using functions all semester, but we haven't really talked about what they are and how we create them. And so that's what we're going to do today. We're going to start writing our own functions and talk about what goes into making a function. So a function is pretty simple conceptually, but it can be hard to know when to use a function and when to replace your code with a new function. We actually did see an example of this last week, I think, when we were looking at Janae's meme assignment, where there was the image of Ralph from The Simpsons, and we wanted to animate multiple images at different times. And using a function was a good way to do that. So that's something that we can kind of go over now. But a function is basically just a block of code that you can call to run the code. So if we just look at a default P5 example, we have our two functions, and as we've discussed a bunch of times, these functions behave differently. The setup function is called when we first start the program, and there's a few different words that we use for functions: call, invoke, run. All of these things basically just mean to say, do the function, do the stuff that's in the function. And so our functions in the default, our setup function just has one thing that it does. It creates the canvas and it sets the width and the height of the canvas. But you can put more code in here, like, I can make variables, I can add, I can draw, I can do other things inside the setup function. Same thing with the draw function. By default, it just draws the background. The difference with the draw function is that it's being called over and over and over and over again. And so as things change in our sketch, the draw function updates what we see on the canvas. So the very basic version of that is we can have an ellipse, and if we just put the ellipse on the page, we just see the ellipse. And if we animate the ellipse somehow, I'm just going to use frame count, then we're redrawing where the ellipse is on the canvas, and we're calling that 60 frames per second. So by creating a function, we have the ability to do something more than once. So, if I just had this code once, like if I just put it in setup like that, it just happens once. We can't update it. But since we have it inside of a function, we have this draw function, we can call it over and over and over again. So as our program changes, we see those updates changing. So a function is useful for a couple things. One is just organizing our code, just putting some code over here and some code over here and not having everything in just one long piece of text. The other thing is that we can call functions over and over again. So we can do the same steps in our code more than once. So a function is sort of like a variable, but instead of saving a piece of data, a variable saves like a number or a string or a Boolean value. A function actually saves code. It saves a bunch of code that we want to run at some point in our program. So this is how we write a function. So I'm going to go back to P5, and I'm just going to delete everything here because we actually don't need to use the defaults for P5 just to demonstrate how to write a function. So to write a function, we start just by using the function, the keyword function. There are different ones in different languages, but most of them use something that sounds a little bit like function. Python uses def, which is like definition, but function is kind of the most general term for this. So you use the keyword function. This is sort of like when you say variable, and then we give the function a name. So I'm going to make up a random function. I'm going to call it banana. just a random name. Your function name doesn't have to mean anything. Usually it's good to name your functions to describe what they're going to do. So setup sets up your program, draw draws on the canvas. But it doesn't have to. It can literally be any sequence of letters that you want to use. You can't use spaces, so I can't write like banana and let's say sandwich like that. That's going to give me an error. So if I want a banana sandwich function, I have to put sandwich after banana, and that's when I'm going to use the camel case with an uppercase letter to make it so that we can see that there's two different words. That's why we get things like create canvas or stroke weight. Those are examples of camel case. So again, that doesn't change the functionality. It's just a naming convention. So let's write our function banana. So after we write the function, we have to put parentheses. That's a difference with a variable. Like if I say variable banana, I'm going to start saying equals after that. But with a function, it's a little bit more like an if statement or a loop. We have some parameters which go inside the parentheses, and then we have a code block which goes inside our curly brackets. So parentheses are always for parameters, like whether it's a condition or the parameters of a function. The curly brackets are always for a block of code that we want to run given those parameters. So after that, we put curly brackets, and usually we hit enter, and when we're inside of our new function, just like if we're inside of an if statement or any other structure, we always move over one indentation so that we can read when our function starts and ends. So for my banana function, I'm not going to do anything too crazy. I'm just going to use the console, and I'm going to say I ate a banana. And when I run this code, so if I hit the play button, even though I said console.log here, notice that nothing happened. That's because this is just a function declaration. Okay, so this is a function declaration. This is basically declaring what the function is and what I want it to do. Okay, so to actually run or invoke or call a function to actually make it do the code, we need to write another line. And so this is a little bit different than what we've been doing with P5 because P5 does some stuff for us. It defines some functions for us. So it's a declaration. You could also call it definition. These are just different terms for the same thing. So you can declare or define a function. So P5 defines create canvas, it defines ellipse, so we can just use those functions. We don't have to write them first. On the other hand, P5 actually calls setup and draw for us. So we write what those functions are, but P5 actually runs them for us. So it's a little bit confusing because we haven't had to do both sides of this yet. So when we want to create our own function, we write the function and then we also call the function. So this is call, invoke, run, whatever you want to say. And so to do that, we just use the name of the function again, and now it's going to run the code that's in there. So now when I run this code, you see out of the console, I get I ate a banana. And I can run banana as many times as I want. So it doesn't do it on 2 lines, but you can see the number 2 there. So that means it ran it twice. And we can add more in code in here. So if I wanted to know how many times I was running the banana, I could make like a variable up here. I could say count equals 0, and then I could say count plus plus, and I could say I ate plus count plus banana. So I ate 1 banana, I ate 2 banana. We don't really need to do that, so I'm going to get rid of that, but that's just an example. So we can call the function as many times as we want to. So the next thing that we can add inside of a function is arguments. And again, we've seen this a lot in P5. Those are the parameters that go inside the parentheses. There's a bunch of different names for these things, arguments, parameters, whatever you want to call it. And the arguments change the way that the function works. So you can think of the arguments as ingredients. And I like to think a bit about this like a function as a process or a recipe and the arguments or parameters as ingredients. So if you think of like a blender always does the same thing. You hit the button, it blends the food, and then you stop and pour the food out, and you have blended whatever smoothie or juice or whatever it is you made. The blender itself as a mechanism never changes, but what you put inside of it does change. If I put peanut butter and banana and ice cream in there, I'm going to get something different than if I put, grapes and kale and whatever. So you can think of the arguments as our ingredients, and then the function as the sort of machine or process or recipe. So let's make a new function with some arguments. So I've got my banana function. I'm going to add some arguments down here. So functions have arguments or parameters. And so if I have a function called greet, and I'm just going to use this function to greet somebody, and we'll see why it's good to have some parameters, to have the ability to change the ingredients of a function. So if I say console.log and I say, hello, Jenny, and that's what my function does, and I call my function down here. Remember, I need to invoke my function. So let's open up our console again, and let's run our code. So we get hello, Jenny. So that function is not very useful, right? I can only say I can greet somebody, but the person has to be named Jenny for it to make sense, and I can only say hello. So I can vary the function in different ways. I could put in a name, parameter. So if I just put in name here, this is essentially like saying this, variable name equals whatever I put in that parameter. It's creating a variable that only exists inside of my function. So it's a sort of like, making a new variable while I'm adding the function. So to use this variable, I have to actually put it somewhere in my code. So instead of just saying hello, Jenny, I'm going to take out Jenny, and I'll close these two strings, and I'll say hello plus name plus, and I'll have to put a space here for this to look good. But now I can I can greet anyone I want to. I can say hello, Jenny, and that'll work the same way. Or I can say greet, and now I can greet Jerry. And so I use the same function to do two different things. I don't really need a space at the end of this, do I? So I have a function that can greet different people. It can greet anybody that I put in as a parameter. So one thing that's a little bit weird about JavaScript is that if I don't have the right number of parameters in my function, it's still going to try to run it. And so I'll get something like this. If I just say greet, I'm going to get this, greet undefined. So that doesn't look good. That looks like you have a problem in your program. And the reason for that is because even though I didn't give a parameter, this part is still happening. It's still declaring the variable because I still have the variable name up here. So this is like when I say something like let x or var x, but then I don't define x. X exists, but it has no definition. So that's why I get hello undefined. There's ways you can deal with that. I can give this a default parameter. So I could say name equals Jenny. And so that'll give me a default parameter so that it'll use that number or a string or whatever the default parameter is in the case that the developer does not put in the correct number of parameters. So we can use defaults like that. There's other ways that we can deal with those issues, but I'm going to leave this as is just so we remember this error. So we can add more parameters. If I want to change the greeting, I'll just put a comma and then add the new parameter. But now my program is different. I'm going to have to add that in here. So instead of hello, I'm going to say greeting. And now I'm going to get undefined Jenny, undefined Jerry. So this would actually be a good place to have a default. Let's say the default is hello. But now I can greet This time let's greet Barry, and we will say hi. Okay, so now we have two different parameters. We can change both parts of our function. So we can say hi, Barry. We can say hello, Jerry. We can say all these different variations of greetings. So we're not going to be greeting people in our code, or maybe you will. I don't know. It could be useful. But this is just an example of how you might write a function with just some simple examples. We are going to use different our functions for different things that have to do with P5 stuff. So one quick note is on scope. And we've kind of talked about this before because we've seen how if you want to have a variable that works in setup and draw, you have to declare it at the top of the program so that it works in both of those other functions. So with scope, if you declare, this basically means where a variable exists. So variables like name and greeting only exist inside of this function. So even though we can see them up there, if I try to log those variables outside of my function, if I say console.log name greeting, I get these errors. And these are the bad kind of errors, the red ones that make my program not run. And so it's saying that greeting is not defined. So this greeting only exists inside of the function. And any variables that I create inside my function will have the same issue. So if I say, variable x equals 10, and then I go down here and I say console.log x, I'm going to get, oops, x is not defined. So again, variables that are declared inside of the function don't exist outside of the function. So that's something that you just have to be careful for. But when we do stuff that requires scope awareness, I'll talk about it in class. So it's not something that you'll probably run into too much. Okay, so that's a note on scope. There's an example here. I'm going to skip over this because it's not super important. Okay, so let's make our own function in P5. This example is actually not necessarily, I guess we could do something with this. I haven't actually introduced the distance function yet, I don't think. But we could do this anyway. I think this is fine. I think this is just an example of why you might want to use a function, which I think we have other ways of demonstrating. Yeah, because I actually want to do the distance stuff later. Maybe I'll move this around. So let's do a different example. I'm just going to use the loop that we've been working with, but you don't have to use a loop with a function. But since we're using loops, we might as well. Okay, so let's take a look at our example. I'm going to save this here, and I'll put a link to this in the voice chat, just a basic example. And then I'm going to open up my loop example from last week. Okay, I have this like frog guy. And so we can add a function in here. And you know what, we can do something similar to what's in the example because it might be kind of fun. We can make this a little bit interactive. Oh no, but it's not going to work because we're doing all this random stuff. Okay, I'm going to add something similar to what we saw with what we were looking at with Janae's project last week, which is like a rotation thing. So I'll go over that. But anyway, so we're going to add a function into a couple places here. So one, and I might simplify this code just a little bit. Well, actually, it's kind of good that it's messy because that's part of what's good about using a function. So one thing that we can do here in our setup function is the way it works now, I have to rerun my code every single time I want to see the new, generate a new copy of my pattern. So one way that I could fix that, remember, functions are useful for a bunch of things, but one of them is to run your code over and over again, to run your code whenever you want to. So if we put the code that we want to generate the pattern in a function, then we can run the function whenever we want. We're not going to put it in draw because it's going to look crazy, but we can put it inside of a mouse pressed or another type of event, and then we can regenerate our pattern without having to rerun our sketch. And so that's actually quite easy to do. The first thing I'm going to do, I'm going to look at my setup function and I'm going to figure out where does the drawing part start. So I create the canvas. I don't want to repeat that, so that stays in setup. And then no stroke, that's kind of where the drawing starts, but I'm only going to do that once. Here's where it really starts. I always want to have a background. Okay, so let's end our setup function here. And actually, let me update this comment here. So let's call this custom function example. Oh, you know what? I need to duplicate this so I'm not overwriting my last one. So I'm going to go to File, Duplicate, and let's rename this custom function example. Okay. And oh, I'll have to edit the old one. Crap. Okay, I'll do that later. So this is a new date. This is April 3rd. And okay, so we closed our setup function. Let's make a new function. I'm just going to call this function pattern. Remember, I can call my function whatever I want, but I want to call it something that makes sense, that people will understand what it means. So if they look at my code, I'm going to collapse these for a second. They're going to see, there's two main functions. There's setup and there's pattern. Okay, so setup probably sets things up. Pattern probably makes a pattern. Okay, so now when I run the code, nothing happens, right? I haven't called the pattern function. And unlike the draw function, which P5 calls for me, pattern is a function that I just made up. So P5 is not going to call it for me. So I have to call the pattern function. So I just type in the name of the function that I wrote. And it really doesn't matter. Pattern is a good function name in this case because I'm making a pattern, but I could call it generate, I could call it make pattern, I could call it create pattern. I'm going to stick with something simple. So I'm just going to call it pattern. So now I run the code and setup calls the pattern function for me. Okay, but it still only happens once because setup only happens once. So if I want to do it more times, remember I can use an event. So I can say function mouse pressed, and we've used this a bunch in the past to save images and do other stuff. And so all I have to do now is just call the pattern function again. It's going to do the exact same code for me. So now every time I run this, it's going to give me a new pattern. So actually I can't rotate my frogs because I'm still using a lot of randomness, which is going to be too crazy without some other stuff. But we can still put it in a function. So that'll be the last example that I will do. And then we'll do some more stuff with functions in a couple weeks when we do interactivity, where we're going to use that distance function that we were looking at before and make some more stuff. But it's not really necessary for what we're working on right now. Okay, so the last thing I'm going to do, I'm going to make a frog function because right now when I read my pattern function, it's pretty crazy, right? Like I have this big for loop, I have all this like stuff in here. And so one way that I can make this easier to read is to separate out certain parts into their own functions. And so let's write our own function to draw a frog. So we're going to make a function called frog. And this function is going to be a little bit like our P5 functions. It's going to draw something. So when we make a P5 function, we say like ellipse, and we have an X and a Y and a width and a height and other stuff like that. And so our frog function can be the same. We can figure out what's similar and what's different in the frog function, and then we can capture that through arguments. So our pattern function didn't have any arguments because it just does one basic thing. It just draws our pattern. But our frogs look different each time. So we can give those arguments for how they should look. So let's move some of our code around. So we need to leave this here because we want Oh, because the frogs are, let's actually just take some of this stuff out because we don't really need everything that we did last time. Okay, so let's just set uh, y to 200. Okay, so we've got some frogs, and let's set the size a little smaller. Oh, that's too small. Okay, and I'm gonna set the face size smaller too. There we go. Okay, that's a little bit better. Just simplify things a little bit. Okay, so the things that are frogs, so the color here gets generated each time we go through the loop. So it's not really part of the frog, it's more part of what's happening with the loop. And then we get the face size. That's the main size of the frog. But then here we can see what's actually drawing the frog. So we first have a circle with X, Y, and a size. Then we choose a random fill that's different for each frog. And then we figure out the size of the eyes, and then we draw the mouth. So pretty much everything after here is the same for each frog. And this is going to be different depending on your design. And you could also just like make functions and just throw random stuff in there and just see what happens. But if we want to go through and figure out which part can we separate somewhere else, that's a good thing to do first. So let's move some stuff over. So let's take our circle and put that in our frog function. So now we can see we need some parameters. So we have X, Y, and face size. And so now if I run this, we don't see anything because I haven't called the frog function, but I can just call frog and then put X, Y, and face size in there. And then that'll go through to my function. And so now I can set the fill. So let's move this over here. And I can draw the eyes and the mouth. I'm just going to move this whole thing over here. And let's use the tidy code button. Okay, so now look how much simpler our pattern function is. So basically we choose a random color, we choose a random size inside of our loop, and then we draw a frog. And y is never changing, so let's throw this up here. So now our pattern is basically very simple. It's saying we start at x equals 100, we go across the page, we go up by 100 each time. And the code is really simple. It's like we want to use a different color each time we draw a frog, and we want to use a random face size, and then we draw our frog. So now I can edit what the frog looks like, and I can think of each individual frog and the overall pattern as two different things, right? If I change the pattern, if I change x to something like 200, the frogs stay the same. So, I don't really have to worry about stuff in here. So we can kind of start to separate as our program gets bigger and longer and more complicated. We can start to separate different parts of our program into different sections to organize them better. So now we have a bunch of functions and we can read them much more easily. If I collapse all these functions, we can say, okay, I have this setup function. So if imagine like I'm a developer, I'm reading some code and I want to understand what's happening because I have somebody said like, okay, you have to, fix this bug that they found or something like that. So I'm going to say, okay, there's a setup function. It's pretty simple. So it creates a canvas, no strokes. So there's no strokes in this project. And then we call the pattern function. Okay, so let's see what's in the pattern function. Well, everything is always at y equals 200. We have this loop, we have random colors, and then we draw a frog. Okay, fair enough. Let's look at our frog function. And so there we go. We can see, and so now I can edit the frog function. I could say, oh, actually, the issue is really this. This fill should be random, 100 instead of 255. So we have less variation on the color of the eyes. You can separate these different concerns into different places. Okay. Um, so I'm going to put a note here, custom function with arguments, and say like ellipse. So the order of the arguments doesn't actually matter here, but we tend to use conventions. So when we write a function with graphics, we tend to start with x, the horizontal position, then we go to y, the vertical position, then we go to other parameters like size, color, things like that. Sometimes if you're writing text, you start with the text, or if you have the image, you start with the image. But there's some general basic conventions that people have, but you don't have to follow them. You could put y before x. You could put size before x. You might have some text that you want to throw in here, like maybe the frogs have names. So you might want to have, I could add a parameter in here. The thing that you have to make sure to do is use the right order. So if I have xy size, this has to match XY size up here. Okay, so that's basically it. I'm gonna stop the video here, and then I'll see if you guys have any questions. We'll go over this distance stuff and these examples in a couple weeks when we talk about interactivity, because this is worth covering, but we don't really need to cover it right now. So yeah, that's it for today. We do have spring break, and then when we come back, we're going to learn about adding interface elements into a sketch so that users can actually control parts of our pattern. So that's what we'll do for the next assignment. If you want to get started on that, you can start adding the functions in like we did tonight. And you can look at these, the DOM elements examples if you want to get started, but you don't need to. You should, have fun over spring break. We'll have time to go over it when we get back. Okay,